It is one of the important topics of econometrics, panel data analysis. We are having today with us Dr. Meenakshi from PES Banglore. We are having our session moderator Dr. IRAM SABHA from Government Degree College, Budgam. So I would over to Dr. IRAM to start the session.
Thank you so much, Dr. Malik Firdaus, for allowing me to moderate this session. Good evening, everyone. I'm Dr. IRAM SABHA, Faculty of Public Administration at Government Degree College, Budgam, Kashmir. I would like to extend my heartfelt thanks to the President of J&K Economic Association, Dr. Malik Firdaus, Jindal Center for Global South Research Foundation, for organizing insightful 7-day online workshop on research methodology and econometrics. It is a wonderful platform for budding researchers to allowing them to present their research and to be the part of the research fraternity. Today's session, I'll be moderating on the panel data econometrics, which is one of the latest and insightful topics. In previous sessions, we have discussed at length about the time series analysis, regression, other relevant topics of economics. Today is about the panel data econometrics, which involves analyzing the data that includes observation on multiple entries over the multiple time and periods. To give the detailed deliberation about the panel data econometrics, I would like to introduce our distinguished resource person, Dr. MEENAKSHI KUMARI, who will give a detailed session about the said topic. She's an associate professor of economics at PES University RR campus, Bangalore. She's an accomplished academician and researcher with a PhD in economics, qualified UGC NET, and certified in applied econometrics from IIT Madras and advanced data handling from IIT Roorkee. Currently, she is posted and teaching in MBA and BSc economic courses. She has served as a data analyst on various ICSSR projects that has achieved with patent recognition. Her teaching interest in advanced statistics, applied econometrics, and panel data and data decisions. Not only that, her expertise has spanned over the research methodology, applied econometrics, and development economics. She has also chaired sessions at prestigious international conferences such as AIBAM 2025, Malaysia International Conference, and presented numerous research papers at leading institutions, which includes even IIMI Bangalore, Lucknow, and IIFT Delhi, and IIT Roorkee. Dr. Kumari is also award-winning paper presenter in Mahasa, Malaysia, and sought after resource person for workshops, conferences on adverse research techniques include systematic literature review and qualitative regression models. Her research interest is ranging from healthcare, labor migration, climate change, women empowerment, panel data, and she is committed educator, academic leader, and she has been an active member for the professional bodies like AIE, IASL, TIES, and JNKE, that is Jammu Kashmir Economic Association and Tribe, Bangalore. This is a very short description about our distinguished resource person. I hope I have justified her achievements. Now, before starting session, I would like to give you a quick reminder about the guidelines of this session. All participants are aware about the guidelines, but still to remind about those that first, you have to unmute your mic. You can open your videos. That is permissible. If you have any question related, any topic, you can raise your hand or put that question in the text box, or we can discuss all those questions at the end of the session, which is question answer session. Now, platform is all to you, Dr. Meenakshi Kumari. Please proceed with the session. Thank you.
Thank you so much, Dr. IRAM SABHA, and thank you so much for your kind words. Very good evening, everyone. It's a pleasure to be here today, this evening, as a resource person on this 7 days online research methodology workshop. So I extend my heartfelt thanks to Dr. Malik, the president of JKEA, and Professor Hebatullah Adam, and the team of JKEA and Jindal South for inviting me for this workshop. I look forward to sharing insights on panel data today. So thank you so much for having me here. So I'll start sharing my screen. Hmm. Because I will be switching from PPT to software, data software. So better I'll share the screen. That would be better for me overall. Right. Is my slide visible to all of you?
Yes.
Thank you so much, Dr. Sabha. Mm, yeah. Okay. So this is all about panel data analysis. You students, you must have heard a lot about linear OLS, ordinary least square, multiple linear regression, cross-sectional data analysis, then time series data analysis. Today, we will go in deep and try to discuss about panel data analysis, right? So the session, what I will cover today is introduction to panel data, what it is and why it is useful. What are the types of panel data? What are the advantages and disadvantages of panel data? When we deal with panel data, what challenges and solutions we have when we are dealing with a complex set of data sets? What are the different models we have, like pooled OLS, ordinary least square method, fixed effect model, a random effect model. And in under pooled OLS, we have three different methods like first differencing or within or LSDV method. We will be discussing on all those in detail. And then we will discuss about which model is better, which model will be perfect fit for our objective, our research. For that, we have different tests like Hosman test and LM test, Bruce Baden test. And different tests we have that we are going in detail to discuss that which model should we choose, either RE or FE, right? And then we will be taking one because it should be practical discussions. So I have planned that we together will extract the data from World Bank and we will clean the data, prepare the data for panel, and then we will start analyzing the data using SABHA software, right? So this is the thing, and then we will open the floor for question and answer. By the end of the session, you should be able to define panel data well and understand its structure. Identify the benefits and challenges of using panel data. You will be able to distinguish between pooled OLS, fixed effect, FE, RE models. You'll be able to understand the basic principles of choosing an appropriate panel data model and appreciate the practical steps involved in panel data analysis. So we'll start with very basics. What is panel data? It is a combination of cross-sectional, that is multiple entities or individuals, and with time series, that is multiple time period dimensions, right? Yesterday, Professor was the resource person, Professor Silky was talking about this two or three lines about what panel data is. So we have in time series, we will be having some variables and we collect the data of those variables for different years, suppose for 10 years or 20 years. But it's a time series data. But what if we have different variables also, right? For different time periods also, like 10 years, 20 years, 5 years, and so on. And we'll be having different for different firms or for different countries or for different states, cities, and so on. Meaning we will be having different firms or state or city or countries for those variables, different firms or countries, and for different time periods. It's a complex kind of data set. So that's why, because it's a long and complex data, that's why we call it as longitudinal data or historical data also. Here, each entity, that is firm or country or city or state, is observed over several time periods, right? From suppose from 2000 to 2025, and so on, right? And for different variables. Now, what notation that we use if we deal with panel data, that is Y or X subscript IT. Here, I have highlighted IT. I is denotes the entity, meaning either firm or city or country or whatever you are collecting the data for. And T is the time period that denotes the time period. So whenever in any research paper you are seeing the model that is y subscript it equal to alpha plus beta x1 it plus epsilon it, that is subscript, then it is definitely a panel data model, not time series data. If only P is there, then time series data. If there is only one subscript that is I, then we call it as cross-sectional model, right? If both are there, meaning it's a uh, panel data, right? That is a combination of cross-sectional and panel data. The example can be GDP of 50 countries over 20 years. So GDP is a variable, 50 countries is the entity, and 20 years is a time period. So we have three things: variable, entity, and years. And similarly, sales of 100 companies over 5 quarters, survey responses from the same individuals tracking annually for 10 years. So these are kind of data sets, we call it as panel data sets. Why we use panel data? Because through panel data, we'll be getting more informations. We'll be able to see more variability in the data sets, and collinearity problem we deal with when we deal with OLS, when we take raw data. We see a lot of multicollinearity. So because when we deal with panel data, we'll be able to reduce collinearity among variables. And we'll be having more degrees of freedom and more efficiency if we deal with panel data model. And it has the ability to control unobserved heterogeneity. That is important. So now, for you people, just you can type in chat box what kind of data set it is. You can see on the screen. Here we have three forms, and here we have 20, and we have three variables: y dependent variable, x1 and x2 are independent variables. You've studied a lot about that through 6 days, all these 5 or 6 days. You must understand that what kind of this data set is. I mean, this table is. Could you type in the chat box?
Ma'am, they are typing, they are writing
Good.
cross-section.
Yeah, great. Kashmiri Das, great. Kiran, great. Perfect. It's a cross-sectional data sets because we have one firm and the data set is collected for the same year, that is 2020. So this is a cross-sectional data. Perfect. Meaning this research methodology coursework is successful somehow. Yeah, this is cross-sectional data sets because observation of the subjects of firms are often at the same time period, that is 2020. Now tell me about this. Oh, sorry. Already explained. This is kind of time series data. I'm unable to do that. Okay, because I can see the chat. It's time series. Perfect, Sayantan. Manisha Ras. Perfect. Yes, it is a time series data sets. Now, because we have three different years, 2020, 2019, and 2018, I have different variables, but not firm. We have only one firm or something, or that is not visible here. So it's a time series data sets, right? Observations are generated over time. Now, this is something that you haven't studied for this on all these 5 days of this research methodology workshop. Can you see here? Somebody has typed, yeah, panel data. Great, Amandeep Kaur and Adiba. It's a panel data. Perfect. Sushma, Sumaya, perfect. It's a panel data. Now we'll quickly see that why it's different from these two cross-sectional and time series data. Can we see here we have from 1, and from 1 we have 3 rows of 4 from 1. For the data is 2020, 2019, and 2018. Again, we have second from 2, and the data is for the same time period, 2020, 2019, and 2018. And we have another form that is from 3, and we have the data for data for the same time period, that is 3 years, 2020, 2019, and 2018. And for all those years, we have variables that is y and x1 and x2. So this kind of setup that is different from cross-sectional and time series data because it's a combination of cross-section and also time series data. So it's a panel data or longitudinal data, right? So it's a panel data and it's a combination of time series and cross-sectional data. Now we understood that what is panel data. Now We have different types of panel data. Let's see this one. It's a panel data, of course. Here we have three firms, firm 1, firm 2, firm 3. In statistical and econometric language, we call it as entities. Because always you will not be having firms. We call it as entities. This side, it may be country, it may be city, it may be state, it may be company or something, whatever. So we call this side firm 1, 2, 3. These are our entities here and variables, right? We have this data sets, this table that is based on three firms for 3 years and for different three variables, right? Such type of panel, we call it as balance panel. Why? Because it's equal number of observations for each firm for the entire time period. And if we see the multiplication that P into N, if we see P is also 3 and N is also 3 into 3, 9. So there are 9 things and so on, right? See the second one here, it is different from the first one because we have the same panel data here. Yeah, it's panel data. No, it's not unbalanced here. It's also panel data. It's balanced only. Why? Because we have one firm 1, firm 2, and firm 3, and we have data sets of 2020, 19. It's a micro panel. We can't say this is unbalanced panel, right? It's a balanced panel only, but because here we have more number of N, that is firms, and less number of year, that is N. P and N. P meaning time period, N means number of firms, number of entities, right? Number of entities is more in comparison to number of time. It's a balanced panel, but again, it's a micro panel. Okay, it's a micro panel because number of firms are more than number of time period. Okay, and right? So this is a kind of, it's not unbalanced panel. Okay? I'll show you what unbalanced panel look like. See this in this table, we have two firms, right? And we have 3 years of data sets, right? Two firms and 3 years of data sets, meaning N is less, P is more. Yeah, macro panel. Yeah, good. Adiba, macro panel. Good, Adiba. So, yes, it's long panel or can say macro panel perfect because the number of time period is more and then the number of n right. We in panel data we do not deal with so 2n and 3p, or we deal with lots of n and lots of p. So just for example, I have kept here two because I can't keep the big table over here, right? That's why. So it's a macro panel, and that was micro panel. When your n is less and p is more, then it is macro panel. When n is more and p is less, then it is micro panel. Okay. Now see this one. We are not dealing with dynamic panel data model, but this table is telling you that it's a dynamic panel data model. Why? Because here we have first column that is firm, second column that is year, third column that is dependent variable, right? Fourth column, if you could see here, what we are taking, sometimes there are certain variables that may be correlated with the past year's same variable like GDP. GDP of this year's must be correlated with the previous year's GDP or inflation. There are many things, right? If you see the effect of COVID also during 1920, suddenly its effect didn't die down. So it took time. So we could see the effect of on 2021 or 2020 also, right? So the variable that can affect by the previous past year values also, that we call it as lag variable. And if we are making another variable as a lag of those increment variable, and this is your one variable, one explanatory variable or independent variable, this YIT will be your dependent variable. But in your model, if yi subscript it minus 1, that is one lag before, if this is also your variable, meaning independent variable, then this model is called as dynamic panel data model. Okay, because it involves lag values of the dependent variable. Right? See, from once 2019 ka value 334 is the value for 2020 for YIT minus 1 and so on. Right. So this is a lag values variable, right? Hmm. So what panel data look like here, if you see, it's also longitudinal as we discussed, right? So it's data sets where the behavior of entities that we just talked about, firm, city, country, state, whatever, company, it observed across time t, xit, yit. I will be from 1 to n, right? And t will be from 1 to t. Okay? So I running from 1 to n and t running from 1 to t capital T. So these entities, three states, companies, families, individuals, countries, as I told you. Now, those were the just basics of what panel data is. We should understand what are the advantages of panel data. If we've thought that in our research we'll include panel data or on a research paper or in our um as as the research topic for PhD should be based on panel data. So we should understand why there's a need of panel data. First thing is that it controls for unobserved heterogeneity, meaning that sometimes what happens, you have collected data from different firms or different countries. There is possibility that firms to firms behavior may vary uh, over time or even the same period, like managerial ability of a firm or can say inherent risk-taking propensity of an individual can vary from one firm to another firm, or like political stability of our country is different from China, or social or cultural behavior is different from our country to China to other countries. Panel data controls for unobserved heterogeneity, right? This is one thing. And it analyzed dynamic effects that we've just seen that what dynamic is. So it explains how variables changes over time for the same entity. Like YIT is there. We are taking lag of YIT, meaning YIT minus one. Similarly, we can take XIT minus one. If we are taking XIT minus one, we call it as autoregressive term. So that study leads and lags in relationship. Okay. So now because if we want to take panel data for our research, then we will be having more data points and there will be more degrees of freedom. Because because as we increase the number of observation and entity, it will lead for more precise estimates and it will increase more statistical power, right? And again, it reduces multicollinearity. What is multicollinearity? When our independent variables are correlated among themselves. If this is the case, suppose our independent variables are correlated among themselves, then the OLS results will be inconsistent or biased, right? So we cannot rely on the results. If we deal with panel data, we can reduce that multicollinearity. We have different methods to reduce those multicollinearities. Uh, we see why we do OLS. We want to see the cause and effect relationship between dependent and independent variables, right? So to get better inference of causality, panel data is the best option. So because it controls for unobserved heterogeneity, okay, and time invariant effects also it deals with, and it strengthens causal inference compared to purely cross-sectional or time series data. That's why panel data is best among all those, because I know that's why I'm telling. So there are, again, these are disadvantages of this panel data, and there are some challenges when you deal with the panel data analysis, because uh, because we are dealing with a complex data sets. So data collection is a big challenge. And if your data is not set for panel, your any software will not be able to help you. So you should know how to clean and prepare data for panel. If more complex it is there, then it will be costly to collect and maintain those data sets. Again, if you are dealing with some current or burning issues, so tracking the same entities over time can be very difficult, right? Because attrition, if we take as for example, attrition in service is a great possibility, a big possibility. Uh, Again, if you have collected data for 25 years, definitely there'll be some missing values. So if there's missing values, meaning unbalanced panel. And if it is unbalanced panel, definitely you need a lot of effort to make it ready for panel data analysis. And it's common and it needs appropriate handling. So this is one disadvantage, or you need proper domain knowledge of panel data. Uh, there'll be complex econometric issues, definitely. In cross-sectional, you face heteroscedasticity, autocorrelation, multicollinearity, not autocorrelation, heteroscedasticity, multicollinearity, and other stuff indigeneity you can face. Here, in time series also we face autocorrelation. In panel data, you may face autocorrelation, meaning disturbance correlated over time for the same entity. I think some message is come. Can we use only 2 periods for panel data? No, 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 no. Pre and post COVID. See, N will be 2 only. I can give you one example. You are going to talk about big thing, and you have only collected mine and your observation. As just for example, cross-sectional. You are talking about job or education, and you have collected data for me and from Professor Sabha. That's all. And you are talking about that education is this, that, blah, blah, and um, in academics we can grow or something. So when we are dealing with panel data, if we have more number of years, more number of entities, then only you'll be able to say something, right? Because only pre-post can be taken, but again, technically, then you need different methods. Meaning, panel, it will be panel, of course, but data should be very clean. You'll not be able to do REFE. Pooled will not work at all. Probably you need dynamic panel data model. Dynamic panel data model, I don't think so we can get good results. You have to do the system GMM. Probably in system GMM will not be able to get anything. Then PCA and many other things we have to deal with. There is very low chance to get significant result if you have only 2 time periods for data sets. And how many firms can we use only 2 periods? Then what can be minimum number of years taken for the study? To balance that, is it necessary to balance the unbalanced panel data? It means unbalanced panel data can be used for the. No, no, no. There's no need to balance the unbalanced data. Whatever you have, just keep it as it is. You don't need to cook or manipulate the data sets. Again, uh, if we have unbalanced data, we need to handle this carefully. That's all. We can get significant result with unbalanced panel data also. We'll collect the raw data. It may be unbalanced or balanced, and we'll see that whether we are getting significant results or not. We'll see. Um, we will discuss Q&A around if we take it at the end, if it is okay. Okay.
I think it would be feasible that we will discuss all the questions at the end of the session. Like this, our main topic will remain then pending. It won't be
That's
possible
what.
for a ma'am to complete all the parameters of a session. So I request all the participants, please you write down your question on your paper. Then we will discuss that in Q&A.
Thank you, Adiba. Thank you, Sushma. We'll discuss definitely. I'll try to curtail my. I want to discuss many things, but in 2 hour sessions, definitely panel data will not get copied. But basics, I want to make you understand how to prepare the data, how to extract the data from World Bank and all those stuff. It need definitely time because we both will do together. And at the end of the session, definitely we'll open the floor for questions. And I would love to answer your question because then only I'll be able to understand that, okay, yeah, I thought something people have understood. Right? So we were talking about,
Please go ahead
yeah.
with the session, ma'am.
Thank you. Thank you, Professor Sabha. Yeah. So we have the complex econometric pieces like autocorrelation, heteroscedasticity, and cross-sectional dependence, of course, because there'll be disturbance correlated across entities, like common shocks. It will be there in different countries or so on. And we model specification in econometrics. We see econometricians they say that model misspecification is a kiss of death. So we need to be very careful which model we are going to choose for our research. If you misspecify your model, your whole analysis will go wrong. You have to start again to do the analysis, right? Okay. So yeah, we have different concepts that you need to understand. One is unobserved heterogeneity. I spoke about unobserved heterogeneity, what it is, and why we are talking a lot about unobserved heterogeneity. See, characteristics of individual or forms that are not observed in the data. but sometimes it influences the dependent variables like innate ability of a person, motivation, or can be cultural background, form shocks, or management quality, organization culture, any company's brand reputation. These are the things, these are the characteristics of any firms or any individuals that are not observed in the data. We are not going to observe these data sets. But again, characteristics definitely affect the dependent variable, that can affect the dependent variable. This kind of things we call it as unobserved heterogeneity. And definitely it will be a problem because if unobserved heterogeneity is correlated with your independent variables, then the OLS that you are using, ordinary least square estimates that you are using, will not be unbiased. It will be biased and inconsistent, right? So we have panel data that these panel data का fixed effect and random effects model. Those are designed to explicitly account for this unobserved heterogeneity. Let's see what panel data models we have. This is the panel data model, general panel data model where we have dependent variable y subscript IT for IT, entity I and time t, beta naught, beta 1 x1 IT plus beta 2 x2 IT plus beta k xk IT and plus mu I plus dit. These two are different. Hopefully, you must have dealt with a beta k xk IT plus epsilon or plus mu I. That's all. But here, let's see what these are. Here, beta, all the betas, beta 1, beta 2, beta k, these are the coefficients to be estimated, right? And this mu I, we were talking about unobserved heterogeneity. This mu I captures the unobserved heterogeneity. We call it as entity-specific unobserved effects. It will not be time variant. It will be time invariant. Time will not affect it. It's a cross-sectional phenomena, right? And VIT, this is also an error term that we call it as idiosyncratic error term. It's time varying and entity varying also, both. But mu I is time invariant, right? It will be entity invariant. So there are three approaches for panel data models. One is pooled ordinary least square, that we call it as POLS. Second is fixed effect model, and third is random effect model. For now, we will be discussing on all these three models. Okay. Uh, Assumptions when we are dealing with pooled OLS, POLS, we have some assumptions. One is mu I, that is entity specific effect, whatever you have, is zero or uncorrelated, meaning that mu I is not correlated with your independent variable. That is the assumptions of pooled OLS, right? It treats all observations as independent, meaning there is no an unobserved heterogeneity. About according to POLS, that no correlation among this mu I and your independent variables. And model will be this one, epsilon. Epsilon I, the last one, this one, epsilon I is including mu I and VI, the idiosyncratic error and entity specific effect. Those both are captured in one, that is epsilon. So there is no any kind of unobserved heterogeneity according to pooled OLS. That is equal. That is almost same to OLS. Okay. Uh, but if we see the benefit of this pooled OLS, it's simple to implement, similar to cross-sectional OLS, and no difference in that. We simply run. But whatever the results we will get definitely be biased and inconsistent, because it's telling that there is no correlation among entity, that is mu I, entity specific effect, that is mu I, and your independent variables, right? It doesn't account for unobserved heterogeneity, and it ignores the fact that observations for the same entity are likely correlated. And the standard errors, whatever you can get, that will be underestimated here if you use pooled OLS. Sorry for the glitch. Connected. Now, yeah, pooled OLS we've understood. That is nothing, just but we use xt command, but it gives us equal results like OLS. This is here we start with panel data. The core idea behind this fixed effect model is entity, whatever I mu I, has its own intercept. Did you see that one thing here? mu I. It's not I, subscript IT is involved in this model. We have IT subscripts everywhere with all the alphabets, but with mu I, we have only I, not T. It means that it is time invariant, right? So each entity, mu I, has its own intercept, mu I has its own intercept, mu I. That captures the time invariant unobserved characteristics. Okay. And for fixed effect model, we have the assumptions that this entity specific is correlated with the independent variables, meaning this mu I is correlated with any of the explanatory variable that is xi, xi can be any x1i, x2i, x3i, meaning that is correlated. That is the main assumption of fixed effect model. And we have different equations. I will just move ahead. Huh? This is the one. So if you consider all 50 firms in the model and assume that intercept of all firms is different due to different factors like capital, production, etc. Then we discuss about fixed effect model. Here in fixed effect model, we have three methods. One is within group effects. Second is LSDV, that we call it as least square dummy variable, and third is first different effect. Quickly, I will explain you this. When we have the first, that we call it as within group fixed effect, here what we do, uh, this is our first model, yit equal to b beta 1 beta 2 xt plus alpha I. This is time invariant plus delta I plus uit. Okay. What in the second model, we do not take the same model. We take y ka average, mean of y and x ka, all the variables ka average. And then what we do the next time, we just uh, subtract the first equation with the second equation. In that process, this alpha I, that is a time entity specific that problem will get sorted out, and our model will be ready uh, to do the revision. So this is the one way to reduce to remove that unobserved heterogeneity. Right? Second model is LSDV. What we do, we suppose we have different forms A, B, B. For A, we give the dummy 1, 1, 1, 1. For B, we give the dummy 1, 1. And at one time, we define the dummy for country A, for second time for dummy B. And we put these dummy variable in the model and we run the regression. In that way also, we can remove the unobserved heterogeneity. The third is first difference effect. In first difference effect, what we do, we take the lag of the previous values, like every variable ka lag variable, y ka previous variable. One time we will be having the same model, yit is equal to this one, which is equation 1. Equation 2 will be not the same current period y values, but the previous period time y value, previous period x values, and so on. And then again we subtract from that we call it as first difference, right? So we are subtracting. In that process also, this alpha I will get cancelled, meaning alpha I minus alpha I will get 0, because we don't have any past values of alpha I, because it's not time invariant. This is the third model of FE. We have three methods to do the fixed effect modeling. So now we have three models, as I have shown you, which is best. So how it controls perform specific intercepts. If we see the within group, when we are taking demeaning, meaning we are taking the average and we are subtracting from present values. So in that process, we remove firms mean over time from variables, right? And it is efficient. There is no need of dummy variables, right? We cannot estimate effects of constant variables within forms if it is, right? If you see the first difference method, it is differentiating over time and it cancels the intercept. It is easy to implement, but it's very sensitive to measurement errors because it reduces data variation, right? And if we talk about LSDV, dummy variable trick, it adds dummy variables for each form. Uh, we can do the direct estimation of forms effects. And if we have many variables, then computationally it will be heavy. Random effect. This is a second model of random data. What is idea behind random effect is that they say that this random effect model, it says that the entity specific effect mu I are treated as random variable. And they say that this entity, if specific effect is uncorrelated with the independent variable. They're not correlated, like, right? So if you see the model will be this one. But here again, mu I and VIP will be taken as one, that is epsilon IT. And this is a composite error term, because they're telling that random effect is telling you that its entity specific effect is uncorrelated with the independent variable, that is xit. How it works? We generalize these square methods to work, right? Because and it accounts for the correlation structures and the error term. It's weighted average of the within effect FE and between OLS P pooled OLS estimators. It is between its weight average of the within FE and POLS estimators. And if we see the benefits of this random effect, it can estimate coefficients of time invariant variables. Since mu I is taken is a part of the error term, it's not taken separately. It's also a part of the error term. And time invariant variables are not removed in this case. If we compare with FE, it is more efficient, but if the assumptions of uncorrelation between mu I and independent variables are there, then only it is efficient than FE. Okay. And if suppose this mu I is correlated with independent variable, then we will be having inconsistent results for sure. So this is the thing about random effect. And now we should run FE and then we should run RE. Which model is best? Which model should be best for our research? For that, we have Hosman test. After running FE and RE, just after RE, we should run the Hosman test. Okay, there will be a dilemma that FA is consistent under both assumptions, that because mu I is correlated, we assume that mu I is correlated with XID. Or if it is not correlated also, FE will work. But RE is more efficient when and only when mu I is uncorrelated with XID. So what is the assumption of Hosman test? Hosman test, it says that random effect is better. We don't need to go to FE. And alternate hypothesis will be just fixed effect model is preferred. Right? So interpretation, when you are getting p values, when you run Hosman test and you see that p value is less than 0.05, then you should reject H0. H0 says that random model is best, random model is suited. So you should go with fixed effect, right? Because it says that because the p values, you are testing that your alternate hypothesis is FE is more significant, and you are going to test, and you are getting p-value less than 0.05, meaning FE model is better. So for that reason, you need to reject H0 and go with FE model. Okay, so the Hosman tests help us to decide that which model assumptions, correlation or not correlation of mu I with regression. That will be more appropriate for your data sets. Choosing between FE and RE, I just have explained you. Now we have step-by-step process for selecting POLS, FEM, or REM. Initial model, whenever we start analyzing the data sets that we have panel data, what we do, we start with POLS, right? First we do the POLS, first descriptive statistics for sure, and then POLS. After running POLS, we should check BP test, that is LM test in statistics, in data, sorry. Bruce-Pagan test, we call this conduct and check whether the data requires a model that accounts for individual effects. Similarly, just that we've done, we discussed about Hosman. Here is this BP test. After running pooled OLS, we should run BP test. In BP test, decision rule will be BP test if you run, meaning it says that no, POLS is perfect. But if your p-value is less than 0.05, meaning no, OLS is not perfect. We have to go with either random effect or fixed effect, right? And if your p-value after running BP test is greater than 0.05, you don't need to go to FE and RE. You can go easily with your pooled OLS result and conclude your result. Again, before concluding, you need to go for all the diagnostic tests. Okay. So this is the first process. Run POLS, run BP test, see that decision rule that p-value is less than 0.05. If it is less than 0.05, go with either FE or RE. After that, you have to go to you have to run FE and then RE. On RE के बाद Houseman test. Houseman test will tell you either RE or FE if null hypothesis is, sorry, if p-value is less than 0.05, you should go to FE. Or if it is more than 0.05, just go with RE and go for diagnostic test. Okay. Now, what we are going to take now, this is 7, okay. Now, we will together extract the data from World Bank, right? And we'll try to do all this. So I'll stop sharing. These are the things that I should explain, data preparation. What we do, if we have wide form of data sets, we make it long because panel data needs long format, meaning each row it should be an entity and variable should be in column. We need to deal with the missing data properly. And we need to create panel IDs for country, IDs for year, right? And after that, after running all REFE, we need to address those assumptions like serial correlation, heteroscedasticity, cross-sectional dependence. All right. So for serial correlation, we have voltage test for autocorrelation panel data. And we have Arellano bond GMM, that is not the scope of this methodology coursework. Okay, and heteroscedasticity, for that we test Waldfest, and FGLS also we do. For cross-sectional dependence, we have PESAR and CD test, right? And that covers it is called Cray standard errors. For robust standard errors, we always recommend using, always you should, like, if you're running the regression, use RE, robust. What robust does, use standard errors, robust standard error that clusters at the entity level account for both heteroscedasticity and serial correlation within entities. So when you're running the RE or FE, use robust also that covers the standard errors also, right? So now I'll share the link. You please click on the link. Just give me a minute. I'll share the link and then we will do together. I've shared one link. Please click on the link. Once you click on the link, you will be reaching to this page. This is Data Bank of World Development Indicators. Once you are done, you clicked on that. We will together extract data. We will customize the data in that way that we don't need to clean the data a lot. We don't need to put a lot of effort in cleaning and preparing the panel data. I hope you guys have clicked, and please show slide 21, slide 22. Okay, slide 22. Okay. This is slide 22, I suppose. Yeah. This is nothing, just whatever I told you, that is the same thing. Thank you, ma'am. No problem, anytime. Please click on this link and open the, please click on the link so that we will be on this page. If you're all in this page, please, somebody please respond that you have already clicked and opened this World Bank.
Anyone from the participants, have you clicked that link?
Yes.
Yes,
Good,
ma'am.
good. We are here, ma'am. Thank you. Good. Thank you so much. Let's see, whatever I'm teaching you, that is very important for your research, right? Extracting the data sets from World Bank and customizing here only so that you don't need to put a lot of effort. First, what will you do? You can see your variable, database, country, right? Layout, style, save, and so on. Here we have country, series, time. Let's click on layout first. Please click on this layout first. When you are clicking on the layout, you can see the draft to rearrange the order, right? If you are on layout, then you click on time. And you see here, drag to rearrange the order, you have column. Now click on this drop down arrow. When you are clicking on this drop down arrow, it is asking for select column, row, page. If you remember your data, your time variable was in row or in column. It was in row. So for time, we will select row, right? And for series, if you remember, series should be in column. So for series, select column. And for country, select again. Country again should be in row. So country and time should be in rows and series should be in column. If you have made these changes, then apply the changes over here. Click on this apply change. Apply changes will be applied on those. Now you have selected the layout that your variable or your time variable, your series variable, your variables, your time and your country. Time should be in row, country should be in row, and series should be in column. Right. Now go to variable. Now here we have country. How many countries? Let's first select the variable. No, first select the country only. If you have clicked on that, we can see here we have different countries, many countries that are all arranged in alphabetical order from A to Z. Instead of selecting the countries manually, why don't we filter over here only? You can see here this filter option, combo filter. Now you have reasons, different reasons we have, based on reasons, income, lending, and so on. So we can collect, but let's collect from reason only. So first of all, South Asia. Once we click on South Asia, checkbox click. We can see here we have 6 options appeared: Bangladesh, India, Nepal, Bhutan, Maldives, Sri Lanka. Click on the checkbox over here. Select all wala. All the countries are getting selected. Now, these are South Asian countries. Apart from that, just only 6 countries will not give us good results. We need more countries. Europe and Central Asia or Middle East, North Africa, Afghanistan, and Pakistan. Once we click on the checkbox, we'll be having all these options. I'm going very slow so that you will be able to understand. Click on the checkbox. Your more countries have got selected. If you see here, country available 29, selected 29. Now go again to filter. You can select at one go also, but I'm just going slow. We have selected South Asian countries. We have selected Middle East, North Africa, Afghanistan, and Pakistan. And again, we are not satisfied with 29 countries. We need more, definitely. Let's see East Asia and Pacific also. Let's see how many countries are coming. We have 66 countries. We clicked on the checkbox, select all. We have these 66 countries all selected. But I'm not satisfied. I need more. So let's take Europe and Central Asia. Click on Europe and Central Asia. Checkbox selected all. Now we have 124 countries. Fair enough? Or do we want more? Let's see one more countries. North America. Okay. North America also selected. Bermuda, Alaska. Shall we select all? Let me check. Okay, 127. Let's select only 126. Any country you can delete. Bermuda I don't want. Or Austria, Armenia. Okay, Bermuda I don't want. I have all 126 countries selected. Available 127. We selected 126. And you can see, if you scroll down, you can see there are many countries all are getting selected. Okay, fine. Country is also selected. Layout is done. Now we need variables, of course. We have this database. I didn't explain you this. This is the database. We are on the World Development Indicators, but we have other also. Apart from World Development Indicators, we can collect data based on our research. Like this is then Millennium Development Goals, doing business, educator statistics, all indicators, gender statistics. There are many jobs, global economic monitor, whatever research you are going to do, if you suppose, you can explore more from there also. We are on this World Development Indicators, and then inside World Development Indicators, we collect it in countries and all those stuff. Okay. So now Our countries are selected. Is there any misses? Let me check. Please share again. Link is already in chat. It's a Google browser, dear. Yes, thank you, Professor Sabha. Yeah. So we've selected all the countries. We are on our world development indicators. Okay. So now we need variables. Let's check the layout, time series. Here. When we click on layout, we have selected the country's time series. If we click on series, click on layout and then click on series, or just to give me a minute, variables. We don't want database. We want country. Here only. Click on, just a minute, click on variables and then drag down. Here you have countries, series and time. Okay. Click on series. Oh, let's collect the time also. So click on time first and then we will select the series. Click on time. I hope you are on the same page. What we are doing, we are clicking on variables. Okay. And then we are dragging down and selecting time. Once we click on time, we will be having recent years. How many years data sets do you want? 5 years, 10 years, 15 years, 20 years, 25 years, 50 years? Definitely I need more. I want 25 years, meaning from 2000 to 2024. So all the years are selected now. Time is also selected. Our country is also selected. Available 25, selected 25. Country available 127 in that particular category and region, and selected 126. Now series, meaning variables are not selected till now. Let's click on series. Once we click on series, we will be having this all the variables in again alphabetical order. Okay, from here we have to collect the variables. I'll make it very simple. First of all, we'll select the GDP. So I'm clicking on this G alphabet. Once I click on G alphabet, we'll be having all the variables. GDP constant 20 at 20 GDP constant 2015 US dollar. So let's click on this GDP. So this is our dependent variable. Okay, we collected GDP. One variable is collected. Now let's click on E. When we are clicking on E, we need export, scroll down because it's an alphabetical order. We need to scroll down and reach to down. Here we are having export. So what do we want? Export, export, export. Yeah, export of goods and services. Percentage of GDP. Yeah, I need this one. Export of goods and services, percentage of GDP. I have selected GDP constant 2015 prices. Export of goods and services, percent of GDP. Export is okay. Now I also need import. Import. Let me click X. Import. So import, again, the same thing we will be collecting. Import of goods and services, percentage of GDP. Click on this also. Now, export, import, GDP is collected. Let's take labor supply and labor, because without labor, we can't do anything. So labor force participation. So instead of national estimate, why don't we take ILO estimate, International Labor Organization. So labor force participation rate of ages 15 to 24. Oh, it's male. I don't want male. I want total. 15, 24 total. So it's total. We can click on checkbox now. If we see here, we have available 1516, okay, series, but we've selected 4. You can select more. For now, for convenience, I'm just selecting 4 variables only. Now, all are set, not set actually. Here, this right-hand side preview space, we can see apply changes. Click on this
Sorry,
apply
ma'am.
changes.
Sorry to interrupt you. Just one
Yeah.
query. I missed it out. Which variable you took? Total estimate. ILO
Uh,
estimate.
yes, yes,
Labor
ILO,
supply. Labor force
labor
participation
force
rate for age. Total
15 to
percentage
24.
national.
Yes, yes.
Total percent national
Total,
estimate or the model ILO estimate, ma'am?
total percent model ILO estimate.
Okay. Thank you.
No problem. We will go slow so that when we click on apply changes, we can see the preview of the data sets. We can see here GDP is in column, export of goods and services is in column, import of goods and services in column. LFPR is also in column, meaning level of participation rate. Mm, And in row, we can see 2000. It's not 2000 only. If you see, if we click on this, it will scroll down. That was for 2000, right? And for different years, it's all showing from 2000 till 2024. Again, I mean 2000 for all those entities. Again, it will start from 2001 or something if you click on. So when I'm clicking this drop down arrow, see what I wanted to show you. This starting now 2001. The whole data sets previously was for 2000. Now 2001 is starting. Similarly, if we scroll down, we'll reach to 2024, right? See. Now, yeah, just to show you. Now it is starting 2002 and so on. It's big data sets, of course. We have different countries and in years, and therefore variables we have, right? Now we have this preview. There is one more change need to be done. Click on this download option. Don't download Excel, CSV, nothing need to be done. Click on this download option. Go for advanced option. Click on this advanced options. First, click on this down. Let me go again. Click on this download app options. Then the last option is download options. Click on this download option. Once you click on the download option, here, can you see here? It's already showing all the details. It's an Excel form that is .xlx. Export range is entire data sets. Data format is table. Variable format is both codes and names. Can you see your NF preference? This troubles a lot when we have panel data or time series data. This NF or dot dot, this troubles us a lot. Why don't we just change this? Instead of dot dot or NA or something, why don't we keep it blank? Because panel data needs blank. If dot dot is there, again, panel data will not work. Panel data needs that cell, that particular cell should be blank, then only panel data will work. Instead of doing editing again in Excel sheet, why don't we select this blank? Once we select the blank, from our data sets, wherever there is dot dot or NA or something, wherever there is missing values, a particular cell will get blank. And that is required for panel data analysis. So now we are all set for downloading the data sets. Now you can click on this download option. I have downloaded the data. Let me click on this and let's check how it looks like. Where is that? You see, the data set is here. I've clicked. You can see, and I hope that many of you must have downloaded the data. In the first worksheet and data sheet number 1, we can see the data view. In the second sheet, this is series metadata. That will be required when you are writing your research paper, when you are defining your variables. Then these definitions will be required. Gross. What is GDP constant 2015? This is GDP, is the total income earned through the production of goods and services in an economy, territory during an accounting period. It can be and so on. Whatever it is there. So you need to write in your research paper and cite and give the references that the data is collected from world development indicators and so on. And we are interested in this one. This is our data set. So if you can see, time is in the first row. Time code, that's okay, is there. And this, just give me a minute.
Hello.
Oh, we have time. We have time period. We have
Shankar,
country.
please mute your mic.
Yeah, I've just bold made the row first row bold. We have time country. Let's click on this country. Double click. Now country is visible properly. Country code is also there. GDP, export, import, labor force participation. These much we required and we've downloaded. Now, based on export and import, you can make another variable that is trade. Export plus import will give you trade. Like that is a different thing. We are not discussing on dollars. If I scroll down, if you can see 2000, 2000, 2000, and it's starting 2001, scroll down 2002, and so on. It will go till to 2024. 3 years for different countries, right? Now, these two lines, data from database, world development indicators, and last updated 7/1/2025, better to delete these two lines because if you do not delete, this will trouble you in Stata. Stata will take you some missing values here, here, and here, and it will take these two cells as some data. So better to delete these two. So delete this and then save. Now we have these data sets. Okay, clean, proper, but again, it's not so clean. Yes, half of the work is done. Some of the work we will do using Stata software. Okay, so if you have Stata software, please click on Stata software. I will just clear because before starting the class, I just tried to do some. You must be familiar with Stata software. Now we have to bring that Excel sheet here. So what we will do, we'll go to File, the top left corner, we have File. We'll click on this file. We'll go to Import, and in Import, we'll select this Excel spreadsheet. Okay. Because I have kept it in downloads. We have to browse from wherever we have kept our data sets. So meaning my data that I have just downloaded is in download. So I could see my data is here. So I will just select this, open. It will get selected, right? Now you can see here preview of this data sets. The first row is showing A, B, C, D, E. We don't want A, B, C, D. What we want to import this data sets. And the first row should be as a variable name. The moment I click on import first row as variable name, our first row become the variable name. If I deselect, you can see it will be A, B, C, D, E. How will this data read this A, B, C, D, E? And how will Stata understand that what this one is time, meaning the data starts from time? How come? It should start from 2000, right? Better to click on import first row as variable name. Once you are done, check well, and then okay. Do you want to continue and lose unsaved data? Yes. Now, when we are importing the data sets on Excel, on Stata, we could see that 8 variables, 3154 observations, and so on. 8 variables. Why 8 variables? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 8 columns we have. That's why it is saying 8 variables, right? Now we can see here that my time is in black in color. And this time code is in red. Whatever is in red, we call it as string variable. Stata tells us that it is not numeric, it's string variable, right? It's not floating, it's string variable. But our time period year is numeric. Our GDP is numeric, export numeric, import numeric, labor force numeric. These are our preview data. Now let's go to before starting anything, we need to rename these variables, right? Found. Now we are in the right hand side, we will be having variables, time code, country name, country code, and so on. All those things stuffs are there, right? First, let's start. I'll go very slow. If I run fast, please let me know. Yes, it's not software. It's anything to me plus. Due to libraries like this. Uh, Anybody has downloaded the data sets? From there, it will be hands-on because you should do with me. Then only things will be, then only you'll be able to understand. Have anybody downloaded the data? Yes, thank you, Sushma. Any other? Yes, good. Amandeep. Dr. Amandeep. So sorry, Dr. Amandeep. Sayantam, thank you, Sayantam. Good, good. Yeah, perfect. Sabya, Manisha, Jagdish, Sable, good, good, good. Vartika. Thank you so much for responding. Let's start our analysis. We first, because these are long variable name, we need to rename these all variables. So better to rename. Uh, let's start renaming the variables. You must be knowing how to rename. We just need to type rename, and we can select.
Excuse me, ma'am. Some
Yeah.
of the students are saying, wait a bit, they are about to open the file, and some of the students are having, participants are having to opening their file. So please help them.
Okay, fine. So I. Okay. Let me know. Yes. Wait, ma'am. Sure, Shankar. I'll wait for sure. I'm not able to open file. How? Oh, you see on Excel file, there is enable editing. Click on those in that enable editing, you'll be able to edit. Have you downloaded Deepika, Dr. Deepika? Mm, where you lack, Dr. Deepika, just let me know. I'll help you for sure.
Deepika, are you there, please?
Yes, Deepika. Yeah, you can unmute and speak, no? That would be better instead of typing.
Ma'am, I have downloaded my file, but I'm not able to open. How I have
Uh,
imported that, but it is not open.
Hello,
okay.
madam. My file is downloaded, but open is still opening, madam. Please wait, madam. Please.
It's not opening.
Yeah, it's
Okay.
not open.
Opening take a time,
Okay.
madam.
Can I share the file in the chat box if it is possible? Can it be possible?
Yes, madam. You can save the file, madam.
Yes, Dr. Meenakshi, you can share in the chat box.
I'll share. I'll share. Okay. Not renaming the file. I'll just simply share the file. Cannot be sent because it's currently in use. Close the file and okay, fine. I'll close. I hope I have saved. If I have not saved,
I
you
think
guys
some of the
need to change.
participant has already shared the file in chat box. Those participants who are unable to download their own, please download it and open it. Kiran,
Thank you, Kiran. That I have also shared. Kiran has also shared.
yeah, please go ahead, participants.
Now, please open the file and scroll down. Scroll down. I don't know whether I have saved after deleting those variable or not. Those data from database or so. I don't know. So if you have, you have to delete it. Scroll down and see that this should not be there. It should be deleted, right? It should be deleted, like last updated data from. Otherwise, it will create a problem. Okay. Open the data sets. Um, mm, see. Now it is saved. Okay. You have to import the data sets. You have to click on file. You have to click on import. No, you have to click on file, then go to import, import arrow. You can see the first option is Excel spreadsheet. Click on Excel spreadsheet. You'll be able to see this import Excel. You'll be having some option browse. If you have downloaded the file, you can browse wherever you have downloaded, either on desktop or download. Go to the file, select the file, click on open. Once you click on open, another preview will be seen. Pop-up window will appear. Here you can see the browse file, right? And because preview is showing that A, B, C, D, E, E. The first row is just alphabet. That is by default this data has. Instead of this, I want to make our variable name, import the first row as a variable name. Once you click on this, then you'll be able to click on OK. And then you can click on OK and then download the data file. Okay. You can import the data file on Stata. I will not do because I've already done. I'll not click on OK. I'll cancel it out because I've already imported the file. You can see here, there are 8 variables because there are 8 columns. If you can see, if you go to how we can go to data view, here on the ribbon, data ribbon, we can see data editor. We can see do file, right? We have do file, this option. We have data editor. We have data editor browse and so on, many options. We'll click on this Penwala data editor. When we click on plain Penwala data editor, we can see our data set. Okay. So there are 8 columns, 1, 2, 3, 4, 5, 6, 7, 8. That's why it is showing 8. And the total number of, you see 3154 observation. Why it is showing 3154 observation? Yes, Sushma?
May I, ma'am, I have a
Yes, Sushma?
query regarding the data you are showing. You are telling us that the ones in red are in string, right?
Yes.
But mine is showing, ma'am, the year time also in red. So that
It's
does it
okay.
mean it
It's
is
okay.
no issues,
It's
no?
okay. It's okay. We will change. We'll rename it. No problem in that.
Okay.
Probably it's. I'll see. I'll open that and then we'll see. Can I get Stata software? I'm not able to download. Stata software. That I have the license version. Without Stata, how will we do? I. That's why in this software case, I can't help you people. Okay. Just learn for now and later you get the software from somewhere, from your university, from your department and so on. Okay. You are telling that your time period is showing red because it's time code year YR2000. That's why it is red. If it is just numerical values like only 2000, it will be black and it is a numerical variable. If YR is attached with this 2000, then this is not numeric values. This is a string. Okay. All these are string, but black is mm, numeric. And if it is blue, meaning you have encoded the variable, like suppose I want to encode country name, then I need encode country name, comma, generate country in parenthesis. Then these all country will be in blue color and it will be in the another column here. That is encoded blue. It will come in blue color. We have made it string to numeric. That's what. Okay. We have these variables. Let's go and do some analysis. Yes, somebody is there. Why string problem is occurred? Sujata. Well, just calm down. No problem. If it is string, we can change it we can encode it. Just it's not a big problem. We'll deal it. Okay. Sushma, it's which up. I can't open. Can I open? I need to download to see. It's open. Let me check. Okay, I don't know why it is in red. If it is in red, no problem, Sushma. I'll tell you what to do, what you have to do. Just for that particular girl only, what you have to do, type in code, okay, and then select that time variable. Just for that lady whose time is showing red in color. Encode, type time. If T is capital, type T capital only. If T is small, type T small only. If not, then select time from here also. If you click that, it will get selected. I've already typed, so I will just delete. Now, encode time, comma, generate, right? In open parenthesis. You want to make changes because it's time. You want to, you should change it as year. So type year because it's year. Close parenthesis. And just enter. You enter. For me, it will not turn because it's already numeric form. If I press enter, it will show not possible with numeric values. So for me, it will not be possible because my variable time already is in numeric form, right? So for you, it will be possible and your variable will turn black. Okay, because you have encoded it as numeric, right? Fine. We'll not go in deep, why red, why black. Let's focus on panel data analysis. It didn't happen, so I just want to delete this unnecessary stuff. I'll just delete it unnecessarily. Okay, fine. Let's start our work from here. Can you see this screenshot? How do we use these things? Just explain you, Sushma, how to deal with string, ma'am. Okay, ma'am. Thank you. Huh. Sushma, I hope you've done. Good. Okay. It gives a sense of satisfaction if whatever we want to teach, people get that. Okay, fine. Let's start our work. We'll first rename the variable because panel data needs small names. So rename. We'll start with time. Whosoever has already, for Sushma, you don't need because we've already changed it in year. Rename time. What do you want? We want year. So rename time year. Our variable, you can see here, time has got changed to year, right? Now, similarly, rename, type, you type, I'll go slow, rename, just let me check how the data looks like. Our country name is in blue, red, sorry. Let's deal with this red wala country name because it needs to be numeric, otherwise we'll not be able to do anything, right? So let's deal with, because it's red, so what we need encode. So we'll encode. Okay, what we need to encode? We need to encode this country name. Click on this country name. It will get selected here. Now, comma, generate. We are generating. Generate, open parenthesis. What we need? Let's keep it simple. COUNTRY country underscore ID. Country ID. Or you can keep its country also. Country ID. Okay. In this way, we are encoding and we are making it as country IDs. Encode, select the country name from the variable side, comma, don't miss the comma also, generate country ID. Now, press enter. Your variable is encoded. Let's see the variable view. Now, can you see here? This variable has got blue, which means we have imported this variable, that is country ID. We don't need this country. We can delete if you want to drop. Here, can you see data? And you can drop selected data if you want. If you don't want, you don't need to. If you want to drop this selected variable, you can drop from here. Should I drop? Yeah, I don't need this, so I will drop it. Are you sure you want to drop variable country name? Yes, I want, because I don't want that, because I've already encoded it as a, is there any chat? No any chat. So I have this country ID in blue form, right? Now, we don't need this time code also. If you want to clean data sets, you can drop this variable also. So there is another method to drop unnecessary variable that is not required. Drop. You can type also drop. What you don't want? We don't want time code. Drop time code. It will be dropped. Okay. So now let's see the variable view. We have country code also we don't want. If you want, let's keep it as it is, and GDP constant and all those stuff we have. Let's go back to this data command window. Now we'll rename. Rename. We have already renamed year. We have encoded country. Now we need to encode the GDP. It's big name, GDP constant 2015 USN and GDP. And data will get confused. Better to make it very short. Always rename with lowercase, not with uppercase. So GDP, small GDP. Simply, let's make it very simple. Press enter. Your GDP variable, if you see in the variable view, it's created. It's renamed as GDP, not created. Rename. Again, you can select from this side also, from your command side, and you can simply delete it. You can select from here. Export of goods and services selected, and we want to make it simple. We name export of goods and services as export only, export. Okay. We type, rename export of goods and services as export. Press enter. This variable has also renamed as export. Now again, select this again, the last command, rename export of goods and services, select this all. And from here, import of goods and services. Now, instead of writing all those stuff, simply write import. Simply type import. Okay, rename import of goods and services as import. Now, this is also done. Now, one more thing. Suppose export import is okay. We want a variable that can be traced. Why don't we make a variable that make trade? Okay, so what we can do for that? Can anybody tell me? If we had to create one variable that is trade, what we can do? Anybody knows? What we will do? We'll write generate. Instead of writing full, we can write G and also it will work. Generate trade. That will be equal to what? Export and plus import. If export plus import is trade, obviously. So generate trade that is equal to export plus import. So if you are completed writing, just press enter. You can see, let's go to variable view. Now, you can see your trade, one more column is created, that is trade. Somewhere you will get dot, dot, dot. Don't worry about that. Probably for those variable we can see here in seventh one, we don't have any values for export and import. That's why it is dot. So don't worry about that, that we have no variables, no, I mean, that is nothing on that particular cell. So don't worry about that. We have just what we did, we added export plus import to get trade. So that's why it is this variable. Okay. So now we have all those stuff. We have rename almost all. One is left still. Again, rename, select all, labor force participation rate, and just type LABOUR, labor. All should be in lowercase. Press enter. All the variables name are created. Okay. If you want to save those, whatever you are typing and it's not going red, you have this do file. If you click on this do file, you'll be able to open a do file and you can save your command or syntax over here and press save, rename it and so on. So I don't want this. I'll just cross it. Okay. Rename is done. Fine. Panel data, these are all our basic things that we use in cross-sectional or time series data also. But for panel data, it's different. Panel data, what we does, we need to tell this data that we are dealing with panel data. For that, what we do, yeah, I'll tell you what we do. We have to show it here. This is my do file. I prepared before the class. Okay, I like the way we have just renamed all those. I have also renamed. Now we have to create a numeric ID. If you can see here for each country. For each country, we need to create a numeric ID. That is the requirement for panel data. For each country, we need to create a numeric ID and for this year variable also. Right? So let's go back. So create that numeric ID. Right? We need to type IGEN. Generate ID is equal to group code, the country code, meaning I will just copy this, but I'll tell you what to type and I can test over here. EGEN, ID, we are creating ID. What is this ID? Group of country code. Instead of country code, because we have deleted that country code. No, country code is there, but instead of country code, I'll take country ID. Okay. So just type EGEN ID equal to group. Ma'am, what is the difference between gen and EGEN? We are creating ID variable. We generate, okay? That is generate, just generating and transforming the variables into encoding, right? Okay. So EGEN ID is equal to group. What we are doing for country, country ID, we are giving ID, meaning if you see, I just told you, if we have to create a numeric ID, and that numeric ID should be for each country. That's why we are getting ID. Okay. So yeah, story. So once you have typed EGEN ID equal to group, and then in parenthesis country ID, selected country ID, parenthesis close, press enter. And if we go back to variable view, you see here ID is created. Our ID is created this side. Okay, our ID is created. Now we'll go back. Uh, mm, Give me a minute, there's technical glitch. Look at this. By mistake, it pressed. Okay, now we have all the stuff. Let me. Okay, so we have created a numeric ID for each country. Now we have to sort ID here. So whatever we have created, that is not in order. So we have to sort. What we have to sort our ID and based on year. Sort ID year we have to type. Sort ID year, right? Type it and just click it. Now we will check the variable. These are the process to deal with panel data. Yeah. Now our ID is sorted. 111 for each country, and then two started for other countries, Albania and so on, Algeria and so on and so on. So it's now ID is sorted. We have created country numeric. We have created numeric value for each country, right? Now what next? We have to tell this data that our data is panel data. For that, what we need to type the command xtset, and that will be based on ID and year, right? ID year, okay? ID year, comma yearly. So that will be based on, you select here ID, okay? Then year, okay? ID year, and then comma. It is a yearly data, so just type yearly, right? And press enter. Oh, sorry, yearly mein I put double L, so that is the problem. Could you see your data sets panel varied ID unbalanced? No problem. If it is not balanced, no problem. But sometimes you may get strongly balanced. Then it is easy to handle. But it's unbalanced panel. We randomly selected some countries, we randomly selected some variables, some years, and so on. We didn't have any objectives to deal with, but yes, okay. This is time variable year, and the data is from 2000 to 2024. It is showing that now it is set for analysis. Okay, XP set ID yearly is the command that we use to tell data that our data set is panel data and it requires panel data analysis. Okay, so now we've done this. Now what next? Yeah. After doing that, we've set. If you go to our yeah, let me show you the variable. Oh, sorry, this is the variable view. Data is not organized in a proper manner. Why don't we order it in a good way? Meaning, let's order the data order in terms of ID then year, no, ID के बाद country, country ID, no, ID later, first time, no, year, sorry, where is year? First year, and then ID, and then country ID, and then GDP, export, import, labor, and let's keep trade also. That's all. Okay, we are ordering the data the data will look like in this way. Order in first column, year in second column, country ID in third column, and so on and so forth. Split. Now, if I go to the variable view, I can see first column is country, then country ID, and so on. ID has gone last. How come? Let me. My system has got slow. I don't know why. Oh, I put the ID in last. That's why it went last. I'll keep this ID in the second place, cross, year, and then ID. Year, ID, and then country ID, GDP, export, import, labor, and trade. That's all. Now, our variable view will be in this way. Year, ID, country ID, GDP, export, import, labor, trade, country. Don't worry about that your data is missing. Probably those data set is not available for 2000, 2001, initial period. But if you scroll down, you can see all the variables are there. In the beginning, we didn't have. So it's not your problem, right? So you can see somewhere it's not there. It's okay, no problem. So let's go back. Let's start the analysis. Whenever we start the analysis, our data is now set for panel data analysis because we have given the data, the instruction that the data that we are dealing with is XT set. XT is used for panel data analysis. Like suppose you want to run regression also, you need XT reg. You want to summarize XT sum and so on, right? If you simply write summarize, what will happen? Let's see. Summarize meaning whenever we start any data analysis, what we do, we see the descriptive analysis. So the same as we are doing with panel data also. Summarize. The moment I click on enter, I pressed enter, I could see that we have variables, observations, mean, standard deviation, minimum, maximum for year, ID, country ID, XGDP, export, import, labor, trade, and country code. Country code, why it is showing 0? Because it's in string. If you can see, country code is in string. The string variable code, it will take as 0. That's why it is 0. Okay, that's why it is for country code, it is showing 0. Fine. But we are just simply giving Stata the command that summarize the data sets. It's summarizing. But this is not simple data set. This is not OLS. This is not time series. This is not cross-section. This is not time series. This is panel data. So we need to tell Stata that it is panel data. What will you do? XT, SUM, XT sum, meaning it's panel data. Now, you want to summarize XT sum. Let's select all the variables from right side. Year, ID, country ID, GDP, export, import, labor, trade. Will not take that string variable. There's no need. If you want, you can take. It will not give more results. XT sum means you are summarizing the panel data of all the variables here, or all whatever you have: ID, year, country ID, GDP, export, import, labor, and trade. Press or enter. Could you see here you have some. This is, ma'am. What is the difference between? Ma'am, will it be okay to share your do files with us? Sure. I'll share. For sure, I'll share with you. Okay. Yeah. So see here, XT sum here we can see earlier we could get a short summary of the data sets that is not sufficient for panel data analysis. Now you see here variable year overall between the mean, standard deviation, mean, minimum value, maximum value, observations. There are 3150 observation of year. Total number of entities are 126 and total time periods is 25 and so on. Total number. Why it was 3150? When you multiply an entity, that is 126 into 25, you'll get 3150. That is the total number. N here in panel data is not total of entity, total of time period. It is P into N is your N. Okay? P into small n is your capital N, right? So similarly, you are getting the overview, summary descriptive of all those variables that you are using, right? You can see here, all are fine. Country ID 11, within 0, ID is also 11. So this is the things. You've got your descriptive. Now, after running descriptive, do you want to see the we want to see the describe. Okay. Somehow the other work I'm clicking unnecessarily. Yeah. Yeah. Describe. Describe will describe your data sets. Can you see all the variable are double and float and all those GDP constant and just giving you the description of all whatever you've done. Just forget about that. We have summarized the data sets. In any analysis, you need to explain very well your summary statistic. I will not spend a lot of time on explaining summarize the data sets. Now, let's see the graph of GDP, what kind of GDP graph it is, XP line. Okay, and then what it is that is it? Because we are taking GDP only. So we'll take GDP and then comma, overlay, off. This you have to type. Let me check. Is the proper command? Yeah. Legend off. We don't want legend. Legend should be off. XT line, GDP, overlay, legend off. We just want to see that what kind of data set is this, how much variation is there from mean values and all those stuff. What is the trend of the rate of this GDP variable? That is our dependent variable, of course. Let's press enter. It will take 1 or 2 couple of seconds to open it up. This is your variable. These 2 lines are showing upward trend, probably that is for export or something. Right? That is one thing. We've seen our variable, right? And now, okay. Now, if you want to calculate yearly mean GDP per capita, we can do. But I don't want to go into deep because it will not give good results. Again, let's see. Meaning we are calculating the mean GDP per capita. The command is by sort year, egen, mean of GDP, and we are creating whatever the GDP we had, uska mean values we are creating. Okay. So this press enter, 4 missing values generated, no problem at all. This is a big command. I'll just select and okay. It's a big command. It will take time to explain. I'll go to chat box and give you the command for this particular. Okay, just copy and paste. Let's see what is happening. Yeah, after this by sort year generate mean of GDP, we have to create a graph that will show individual GDP and yearly mean. Let's if you have copied and pasted, let's click press on enter. It'll take a couple of seconds to see the. So this is the overview of GDP per capita constant. This red line, if you could see, showing that the mean values here, but your data points are varying a lot. So it's dispersed a lot. Your mean value is this, just to show that where is our GDP capita and our mean GDP per capita per year is what, right? So it's not necessary, just wanted to show that what it is. This is not our interest. Let's go back. Similarly, we can see XT line. Instead of GDP, we can select for other variables also, and can see the graph of other variables also, right? Now, let me start. Yeah.
Yeah, excuse me, ma'am. Can I ask one question?
Sure.
Yeah, so this by sort command, what it will do? It will do the average of GDP.
Yes, correct. Average of GDP of all those years, for all those years. It will create a variable that is
Create
maybe average.
another variable it will create.
Yes, correct.
Okay, thank you.
See here, If you can see variable view, mean of GDP created. In variable view, you can see here the mean of GDP created.
Okay, ma'am. Now I have one question over here.
Yeah.
If let's say I have one company and the financial of 5 years, right? And then I want for one company, if I want to take the average of 5 years data, is it possible in Stata? I mean,
One. What average of what?
so for example,
Question.
for 1 year, for one
Uh,
company, I have
uh,
5 years of profit.
To take the average of profit, easily it will be done. Of course, it will.
Yeah, but
You can.
then it is a panel data. So I need a
How can it be panel data, dear? You have only one company and you have 5 years
but
for
then
data
yeah,
sets. It is a time series, right?
no, ma'am. But then similarly, I have another company with 5 years data. So that's what I'm
Jayadeep
telling.
Singh, what happened, Jayadeep Singh? Yeah, you tell, please.
Yeah, ma'am. So
Please
there are
don't disturb the screen. All participants are strictly guided.
Okay. Yes, please ask quickly because we haven't started FERE till now.
yeah, ma'am.
Ah.
If you want, I can ask later on. That's also fine with me.
Kinjal, do one thing. Ask all your questions at the end because we are
Yes,
running out of
ma'am.
the time.
Yeah, ma'am. I can do
Yeah,
that. Thank
actually.
you.
Okay,
Yeah.
now let's start with FE model. As we have started that, we will start with pooled OLS, right? So for pooled OLS, what command we needed it streg xtreg, right? Xtreg, and then select your dependent variable. For our data sets, GDP is the dependent variable, xtreg GDP, and then select export, import, labor. Don't select trade because if you select trade, trade is a combination of export or import, export and import. So either select trade or select export and export and import. So GDP, export, import, and labor, right? This is simple command for POLS. Click on that. You will get the result. Right here, if you got the result, we have 292494 variables and within, between, and so on. This is pooled OLS, right? Simple pooled OLS model it is. Now we'll run the we don't need pooled OLS because it's already unbalanced panel data. So we'll go with FE model. FE meaning fixed effect model. So how to run FE model? Same model. Just select this variable, but instead of just keep this stopping over here, comma, select write SE. So not capital, small SE. FE meaning you are telling Stata that it is a panel data, but we want to run FE. FE meaning fixed effect. Run FE. Okay. Now press enter. The moment you press enter, you will get the result that we get. Yeah, FE. Here we've got the result of FE. F value is 34.38. Probability is P value is 0.000, meaning good. You can go ahead, right? And but again, what we need after FE, what we should do, because we are interested in comparing also. We have one command that estimate, right? Estimate store fixed. We have run this FE, right? Right? Type estimate and store FE. FE or fixed effect. Meaning, whatever you have run here, you are telling Stata that to store it because we need it later. So, estimate and store FE. This is the command that you are using to store this model. Okay, store fixed or store FE. Let's type fixed only. Fixed and click on that. That is stored now. Now again, you run the model, same model, but instead of FE, this time you type RE, meaning random effect. STREG, GDP, export, import, labor, RE. Now press enter. You will get this random effect model ka result. Now again, we want estimate. We want to save this. So estimate, store, and what we need this time is we want random, not fixed, random. Okay, estimate, store, random. Now this is stored. We have stored both, right? Now we want to compare, right? So estimate, store, random effect run, estimate done. Now we want to diagnose test which in the theory part we were discussing, no? This is a dilemma. Which model is good? Fixed effect or random effect? For that, what we'll do, we will do Hausman test. For Hausman test, what command is required for Hausman test? Because Hausman will tell you either we need to go with FE or RE. So we'll type directly Hausman, and it will tell fixed or random. So type fixed, random. Hausman, fixed, random. Okay, and then press enter. Now it is giving you some result. You people will tell me which model should be uh, good to go ahead, FE or RE. You have the result. Fixed का आपको मिल रहा है export import labor random effect. Both का difference B minus D, and then this diagnostic test also. These all are highly significant. That's okay. P is consistent under HO and HA is often from ST rec. That is giving you the summary of those. Our interest is to see this. Okay. Okay. Chi-square. Chi-square value is 0.000. And what will you do in that case? Which model is better? Somebody is type. Can't copy them. I'll share the do file. Don't worry, you will be able to do. Perfect, Angelique. Great. It's because p value is 0.000 and p value is less than 0.05, meaning that RE will not work. We need to go with FEs. But again, we will not go with FEs. We need to do another test also, right? If we see the results, let's go back to the result of FE. Can you see here FE? Meaning this is FE ka result. We have F value 34.25, the beam 0.0. Here, the beam between overall, all we are getting the result. Uh, it's not so highly because it's definitely in a panel data we are not interested so much in R square value, but and you know what this rho is? Rho is sigma u by sigma u plus sigma a, and what this sigma e and a are? These are standard errors. Okay. Um. Let me yeah hold. So yeah. After deciding after this getting that okay, the fee is more efficient in comparison to RE because p value is less than 0.05. So we'll not stop here. We need to go with diagnostic test. That is unit root test. We call it as stationarity base. We see the stationarity of all the variables. We test the autocorrelation and unobserved heterogeneity and multicollinearity. All those stuff we do. Apart from that, if there is any problem, we are not getting good results, we can transform the values into log form also. Like we just see, we saw that our variables are far from mean value, right? Our variables are very far from mean value. So, and if we go back to our data also, we can see here that our GDP is in lakhs, export is in thousand decimal points, of course, and GDP is in lakh values, labor is in decimal point, trade is also less values, and other values are less, but GDP is high. So in that case, the data is completely skewed. I could see, if you want to see, you can type histogram of GDP. See, the data is completely skewed one side, right? High values GDP. So instead of seeing that, why don't we transform the value, generate log of GDP. So we can generate ln underscore GDP for what? GDP. So we can generate we can create another variable that will be the log of GDP, right? Generate log and that variable will be created, okay? Equal to GDP. Equal to directly you can select from here. and your variable is now LNDP. If you go to your variable view, we do all sort of things to get a good significant result. We have another variable that is created, that is LNGDP. Similarly, we can create for other variables also, and we can get good results. Let me create for all the variables, so that why we do log transformation, no, to normalize. We saw that our variable are completely skewed. GDP is skewed. See how it is skewed. How will we get good results? Instead, so better to transform the values into log form. Okay, so that it will normalize. GDP ke jagah pe, why don't I take export and then export? So this is also sorry. There's a space here. We can create for all, we can transform all the variable export ki jagah pe import in log form, and then we will run the model again. Import. What is happening? There's a space generating, that's why it is enter. Okay, I'll type then gen. What we are interested? Log of ln underscore labor and equal to labor. What is the variable? Variable is labor. Now we are all again there is a space, that's why it's ln of labor. And now if you want to go back to our variable data, you see ln export, ln labor, ln export, import, ln GDP, all log variable we have created. Now let's run the model again. xtreg.
Ma'am, it has not created the log value actually. If you see the labor, both the data is same.
Probably for me, for you.
For you also, ma'am.
No, it's created. I'll show you.
Uh,
Let me check and see.
Can
It
you
has
check,
created
ma'am?
ln of GDP, ln of export, ln of import, ln of
Yeah,
labor.
it has created, but if you check the value, it is same because it has not taken log. It has just created the value, created a new variable.
Just give me a sec.
For export, if we check, no, it is same. For
It is same,
import,
correct.
I think we missed. I think log we have to use somewhere.
Wait. This is open. Give me a minute, huh?
Yeah. I think it is generate ln import is equal to log in a bracket import. That will create log.
Generate. Pick up again.
ln I mean export, but it is already generated, so you have to give some other name. Is equal to log, then in a bracket GDP.
Correct.
Correct.
100% correct. Yes. You're right. Why don't we drop all the variables? That would be better, no? Drop.
Yes, ma'am.
Let's drop all those stuff. Drop. One more is there. Let me drop all those unnecessary stuff that is created. Now, we'll generate ln underscore GDP equal to log of. Now it has got changed also the color. Now it will generate for sure log of GDP. Parenthesis close. Oh, it's not should be equal to only one single equal to. I just created. Let me check. Yeah, it is created 24.24 and it was earlier 3.369 e raised 10. So now it is 24.2. If you see from other variables, which are matching. We don't need to change other variables from other variable into log form. Our GDP has already normalized all the variables. So, or we can create, sorry. I don't know what I deleted. Okay. Anyways, data view has deleted that will be created. Okay. Better to create generate all those variable LNGDP this time export and here export enter. Similarly, create for import and log of import. Labor. Now all are there. Now we'll run the command again. xpreg. Select all the log values. ln GDP, ln export, import, labor. Okay. Again, FE model, FE. Let's see comparison of those models. Yeah, it is better than the previous one. So we can check and get the idea that what these all things are. The probability of p-value is highly significant in this case. Earlier it was not so significant, I suppose. FE. P-value is not significant here, if you can see. But when we transform the values into log form, we could get significant result. All the variables are significant. You can also deal with that. If you put robust, it will deal with standard error. Robust standard error. We were talking about robust. So if
Sorry,
we just
Dr. Meenakshi, we are
yeah.
running out of time, so we probably having 10 to 12 minutes.
Okay, I'll just finish the talk. Okay. So this is robust. If you just type robust, it will deal with the standard error extraction of variable due to UI and so on. We'll get. Similarly, we can run the RE command, FE, and now we can do RE, and then robust. We should go with standard error. Okay, robust. We'll get the result. If we, it deals with standard error also. Okay, so robust standard error and those stuff is done. After doing all those, Horseman. For that, again, we have to save, store, estimate, store, FE, estimate, store, RE. After just running those FE and RE, and then we will compare to Horseman test and get the idea that which model should be better for us. So after doing that, we can go with diagnostic test, that is LM test. Right? Let's see, Horseman test is done. We need to install XT set, XTTEST command. We need to install to run this LM or serial autocorrelation things and all. Let's first run the robust XTTEST, that is LM PES test. So for that, we need to install this SSC install XTTEST2. Okay, if it is installed, then well and good. It is for me it is installed, and now it is installed. So we will run the command. That will be the same, just we will add XTTEST, right? So we have this command that we have already run. We'll run, and then XTTEST. Let's check. XTTEST is not required for now, so we will after running the model we need. Okay, we'll run and then XTTEST 2. Okay, 2. Sorry, so we need 2 because we have installed XTTEST2. The moment we click on XTTEST2, we will get the result. we've got this result. This is the test for this is a diagnostic test, okay? To few common observation across panel to compute full rank VCE. Okay, this is the command that we use to see that. It's a big one, still coming, no observation and so on. Just leave it now. Now, for heteroscedasticity, either it is available or not, we need to install XTT, ST2 or 3 for PESARN test. We need XTSCSD, right? So again, we need to install SSC, install XTC, SD. Okay. And then if it is done, then we will run XT unit root, IPS GDP. That is, we are taking the stationarity of this GDP variable, XT unit root IPS. IPS is a PESARN test, right? It will give us the idea. No observation. Okay. If it is unbalanced data, no, to sum up the diagnostic test. Is that coming? There are 3 tests: PESARN test, LM test, and those all stuff. For unbalanced data, some of the tests will not work. For balanced panel, all the tests will work. That is one thing. If we want to check the autocorrelation in the data sets, we need to go with install XT serial. And for IPS, it's not working for our data sets because it's unbalanced panel. Okay. For autocorrelation, SSC. In my system, I don't know, XT serial, that is the test for autocorrelation, doesn't support. If your system it is supporting, then you can test for autocorrelation in the data sets. And there are other thing also.
Hello, ma'am. Command is wrong.
Yes.
You have to run the SSC install XT serial.
Oh, yeah. Thank you so much. Install ko I forgot. But in my system, it's not working. This is status 17. So there will be another not found in my things. I checked all those stuff. It's okay, but for you in your system, if it is working, then you can go ahead and check. Apart from that, after doing FE and RE, you need to check. You need to do all the diagnostic tests. If the data, all the variables are stationary, you can go ahead. You can conclude your analysis, right? Um, hmm. So in this do file, apart from making the same variable and transforming into log, I have made different regions like Asia, another region, China, Europe, France, and we named also, and we used all those to make it as income group: high income, low income, and below emerging economy, and low income and high income countries, and mean GDP and all those I did. And again, I run the regression, use GMM also later. So I could get good results. This is just basic RE, FE, and uh, those tests, diagnostic tests that we have. I am PESARN, XT serial, and BPG test, LM test. Those are the tests that we used for diagnostic test. And Osman to choose FE and RE. Okay. Yeah. So commands that we use are those FE, RE, and for XT test is for BPG test and all those. See, this is these are the steps that we follow. First, we prepared the data. We did the pooled OLS. We did the FIST effects. We ran the random effects. Then we take the Hausman test. We prefer which one to select which one is better, FE or RE. And then for checking RE is preferred or pooled is preferred, we go with BPG test. And for robust standard error, we use robust ROBUST, right? We see we clustered panel ID and all those stuff we use. And so then we do auto diagnostic test, that is for autocorrelation, heteroscedasticity, and multicollinearity. Right? We have Wooldridge test for multicollinearity. And then based on that, we interpret the results and conclude. Okay, this is just to, I had to explain this, what this result shows to us. We are running short of time, as ma'am said. So I will try to conclude. If you have questions, please ask. Okay. These are the tests that we use for diagnostic tests. Okay, Levin-Lin-Chu test, PESAR and IPS, and Fisher type and Haji test. This is my email ID. If you want to take the help of mine in panel data, I'll definitely help you. You can send me your queries through email also. And these are the recommended readings for a better understanding of panel data analysis. Thank you so much. And because of time lag, we could not go in deep in panel data analysis. But again, thank you so much for having me here. I could not finish it up properly.
Thank you so much, Dr. MEENAKSHI KUMARI. It was a wonderful and insightful session. Both theory and hands-on practice was performed in this very session. Thank you so much. As you know that we are running out of the time and we couldn't complete other things. So if you have any question to the MEENAKSHI, Dr. MEENAKSHI, please put your questions on chat box. There are some questions as you have already answered them before, but let me read the new one they have put up. First is by Sushma Shubha. No, first is like Anjali. You have answered that. Then Sushma. She said we failed to reject the null hypothesis.
Sorry?
We failed to reject
the that is her reply for that Hausman test. She replied that we failed to reject null. We will go with we failed to reject null hypothesis. It was her reply, I suppose.
Okay. Anjali has put like this. Please explain the fraction of variance due to nu I.
So come again. So sorry, ma'am.
Please, Anjali has asked. It's in a chat box. Please explain fraction of variance due to nu I.
Fraction of
variance.
Fraction. I didn't see the message. Let me check. Fraction of variance. Can you ask again? Whosoever asked, can you please type again?
Ma'am, I wanted to ask, in the regression results we got, I think it was almost in the last column, fraction of variance due to mu I. So what is the interpretation of that?
Fraction of, just a minute, huh? Fraction of, shall I open the PPT, dear? If you have time for 2 minutes.
It was in Stata results. In Stata results.
Okay. So
when we ran FE
Anjali, you can do one thing, as ma'am has already put her mail in the chat box. You can have that and directly contact on that, because we are literally running out of time.
Okay, ma'am. Okay.
I think that would be preferably good.
Anjali, yeah, I'll type my email ID. Please contact me.
Okay, thank you, ma'am.
Yeah.
Sujata Kumari is asking, ma'am, you didn't clear about the string issues.
String issues will be, and see, if that variable is required, you have to type in code, then the variable that you want to string, comma, generate, and then give the name of that variable, whatever you make the short name, and put it in parentheses and press enter. That variable will be string and it will encode. You get a turn blue and it will create another variable that name, that whatever name that you have selected with the name with the name of that variable. I hope I
Another
have explained.
question.
Meaning, see, if you want to de-string, you have to encode, then select the variable that you want to de-string, comma, generate, in parenthesis, give the name of that variable, whatever name you want, close parenthesis, press enter. That variable will turn blue, and there will be another variable will be generated with the new name.
Another question is by Sabha Yadav. She's asking, do we need transform all the IVs, or we can transform only variables that are skewed?
We need to transform. We need to generate the numeric ID for country, for each country. That is important for panel data. Meaning for each country, we need an ID. Like for Afghanistan, we need to generate an ID for 111 for Afghanistan, 222 for Albania, and so on. For that, we need ID variable. That
Ma'am,
is required for panel data analysis.
yeah, actually not ID, log transformation we were doing for all the IVs. So I was asking if a log transformation is needed for all IVs or just for the variables which are skewed.
That depends on your objective. Suppose your GDP is highly skewed, transform it in log form. And other variables are in decimals only. And your GDP variable is in lakhs. And other variables are in decimal, two digits ka, and then decimal. Definitely, your results will get affected for that. Transform this GDP value into log form. If suppose there is a lot of variation in the data, so transform all the variable in the log form. See that what kind of numbers you can see on all those variables. Run the regression. See what you are getting in return. If you are getting significant results, go ahead. And it's all we should try a lot, right? To normalize the variable, we do log transformation. I hope I have answered Sabya.
Okay, ma'am. Thank you.
Another question is from Sayatan Boha Majumdar. He's asking, when should we use GMM?
GMM is used when we have small n and large t. And in that case, we will get indigeneity problem. Right? Indigeneity problem is a big problem for any data set. And suppose we have five firms and we have 20 years ka data set. So somewhere you will get some problem. So after running FE, RE, robustness, standard error robustness, and all those stuff, go with dynamic panel after checking because I am iron test and XT serial autocorrelation. You will definitely see some kind of autocorrelation among independent variable, meaning there is an indigeneity problem. If there is indigeneity problem, but only GMM can sort it out. GMM can sort any kind of problem. So go with GMM. If GMM is unable to sort it out, then go with system GMM. PCA we have another things we have. Advanced level, of course, but we select GMM when we have small n and large t. And when we have indigeneity problem.
I hope you got the answer. Another question is from Kavita Meena. She has asked, what is the difference gen E and egen command?
Generate command is just generating one variable. Generate is just generating one variable. Encoding and generating in egen command. Yeah. I hope I have answered her.
Okay. Kinjal Mahani has asked, is there a minimum observation required like 1,000 or something for panel data?
It's not necessary. If you have small panel, less number of years, less number of n, then you may not get good results. Go ahead with good big data sets. Suppose you have 20 years ka data sets and you have only 5 firms, no problem. Definitely, you need to do a lot of things like RE and FE will not work for sure because there will be some problem. Heterogeneity, precipitacity, autocorrelation, multicollinearity definitely will be there. Then you have to go ahead with GMM, system GMM, PCA. You need to include PCA because I have analyzed those data sets also, whether they have only 5 firms or 5 countries and 20 or 25 years ka data sets. We can go ahead. It's not compulsory that we need 1,000 ka data sets, right? But yes, just take the example of cross-sectional data. You are going to analyze the data. You have only 30 observations. Will you get significant result? Obviously not. Same happens with panel data. If you have only 5 firms or 5 countries or 5 states, and you're going to analyze, you're going to tell that, okay, this is a big impact of export and import on GDP, or so on and so forth. If you collect more countries and if you're taking more number of variables, more number of years, then you'll be able to say something that will be not biased and consistent or efficient results. So in panel data, our motto is take more number of data sets, so it will give you results. But again, depends on your research. If your research is based on, like one girl asked that pre-COVID, post-COVID, yes, you can do, but here it will be again cross-sectional and panel. It will be panel is just year is just 2 years ka data sets, and I don't know how many firms or country you are going to take it. There will be problem for sure. You may not get significant result. That is the thing. The more the variable, the more the significant results you will be having. That is the thing. So
Good
in
evening, ma'am.
cross-sectional data, yeah, just a minute. In
Good evening,
cross-sectional
ma'am.
data,
My question is when we apply the fixed year effect or fixed entity effect in the running of the fixed panel data.
yeah. So we have 3 methods in fixed effect. One is demeaning, that when we have to use demeaning, first difference, and LSDD, that is dummy variable things, right? We have to try all those stuff, right? Demeaning when we use in entities, again, all these 3 methods are used in different way. Method of FE, we use FE methods just to remove those unobserved heterogeneity, right? Motto is the same. Either you use first differencing or you use demeaning of those variables or you use dummy variables. You should use all those 3, compare the results, like estimate, store those results, and then compare the results of all those stuff, and then see that which method should be best for removing those unobserved heterogeneity again. So FE, in FE, 3 methods, go ahead, analyze using all those 3 methods, compare which one is better and go ahead. Again, we have some theory also, definitely, that right now needs a lot of explanation.
Okay, we'll be taking the last 2 questions of this session. After that, no question will be entertained. If you have any query, you can mail to the ma'am. There's a question from the Jasprit Kaur. She is asking about, if we have 2 countries and data of 24 years, then can we proceed with the panel data analysis?
Same reply. You try, you start analyzing. How many variables you are having? 2 years, 2 country, 4 years ka data sets. How many variables you are having? Some multiply, or T into N. Check how many variables you are having. Definitely, you will get some sort of results. But again, you need to go with GMM or system GMM because same reply with 10 observations, 20 observations will not be able to get significant results. But if we have, as per cross-sectional data sets we're talking about, standard, including the sample size determination, we need to collect 285 samples, right? Then only we can get good results, significant results with primary data sets. Same is applied here also. It's not about primary data, but it's secondary data. The more the data sets you will be having, the more you'll be able to get tell something, or you'll be able to explain something about that. The same principle rule is applied here also. If you are having two countries and 4-5 years ka data sets, you can analyze for sure. But complex models will be there, GMM, system GMM, PC, including PCA also in your system GMM and GMM. Then, of course, yes. But complexity will be more. You may be you will not be able to use lag because you have only 4-5 years for time period. There are complexities, that's the thing. But again, you should try to run those models. If you get significant results, thumbs up. But complexities are there.
We have another question. If FE appropriate as per the Hosman test, the result of RE2 in our research report.
Ma'am, please come again. I missed you.
If FE appropriate as per the Hosman test, the results of RE2 in our research report. This is asked by Goham Mujumdar.
If according to Hosman test, if FE is significant, then RE is?
RE is 2 in our research report. He's writing like this.
We should definitely write because whatever we have experimented, we should explain in our research papers. If not, you should put in appendices so that the reviewer will be able to okay, this is the result that person has, or not. Put the in appendices, but mention in your results that yes, you've done RE, and after Hosman test, the p-value was less than 0.05, so you are going with FE. Again, you will not stop here. You have to go with diagnostic tests. You have to check the stationarity of all those variables. If all get satisfied, then only you will be able to say something about your results. Right. And
we have last question by Adiba Beg. What to do normalize data if value contains 0 or negative values?
For negative values, we have log regenerate var, and for var +1 we do for log transformation. When we have negative values, we have one command in Stata that we generate variable +2 or +1. So another variable will be created, so there will not be negative values, and we can deal with that. But if we have negative values, suggested not to transform in log form. Yeah.
Thank you so much, ma'am.
Just a minute, ma'am. Guys, if you have less number of N and more number of T, you have to go with GMM and system GMM. Those are wonderful models. I love GMM and system GMM, working with system GMM and GMM. Whatever problem arise when you run RE and FE, you may get autocorrelation, some sort of stationary, the variables will not be stationary. That stationary is different thing, autocorrelation, endogeneity, heteroscedasticity, definitely unobserved heteroscedasticity, multicollinearity, all those stuff are there. But when we deal with the GMM or system GMM, all sort of problem will sort it out through GMM and system GMM. So if you have less number of and more number of P, good. If you have domain knowledge of GMM system GMM, go ahead. Your paper will definitely get selected somewhere to use generalized methods of human and system GMM. So don't worry that you have less number of less number of N and more number of years. Try. We try and then we learn. If problem, add more, right? If you have two countries, there's problem in running the analysis. Add more variable. The more you try, the more you'll learn. So that is the thing. Apart from REFE, GMM and system GMM is the best. Are the best. Okay. Yeah. Urmila, do you have any question, Urmila? Yeah.
Actually, we are out of time now. We have to wind up. So,
okay, sorry, sir.
Participants, if you are having any question, you can reach our resource person. I will be tagging her on our LinkedIn, and she have already shared her email ID. You can reach her. So, thank you very much.
Thank
you
you,
can conclude actually. Meanwhile, I request all participants, if you are able to open your camera, you can quickly. And I have shared with you poll, which you have to attempt till 9:05. Okay, you are having more 4 minutes. So please open your camera. We are going to wind up. Hiram, you can go ahead.
Okay. Thank you so much, Dr. Meenakshi Kumari, and I would like to extend my thanks to all participants who have obediently abide all the rules and regulations of this session. Thank you so much. I hope you got insightful session regarding the theory and the hands-on practice. Thank you so much, ma'am. Thank you so much. And thanks to all the participants.